number 1, a point is moving along the curve y equals to 2x plus 5 over x in such a way that the x coordinate is increasing at a constant rate of 0.02 units per second. Find the rate of change of the y coordinate when x equals to 1. Now this question is a rate of change question, since this rate of change is appearing over here, which is a clear-cut indicator. Secondly, you will get per second, which is dt. Let me write it down. You have dx by dt given to you in the question as 0.02. You have this is dx by dt. So x coordinate is increasing, that is the rate of increase dx by dt. Since it is increasing, so it is positive. And the value of x is 1 given to you, and you have to find the rate of change of y coordinate. So dy by dt is required. So what you will do, you will first of all write down the equation of the curve, which is y equals to 2x plus 5 over x, and if you simplify it, it will become 5x raised to the power minus 1. As I told you in the lecture, first of all, you will take dy by dx, and the derivative of x is 1, so this will be 2. 5 remain as it is. You will take derivative of x, power come first, whatever power minus 1, so this will become minus 2. So this is 2 minus 5 over x square. X square. Since the value of x is given to you, so you always go for the value of dy by dx, not the expression. So if you plug x equals to 1, you get dy by dx 2 minus 5 over 1 square, which is 2 minus 5, since 1 square is 1, and 2 minus 5 is minus 3. So now dy by dx is minus 3. Now you can apply chain rule. Now the chain rule is that dy by dx is dy by dt divided by dx by dt. So if you plug the values, dy by dx is minus 3, dy by dt you are looking for, and dx by dt is 0.02. Cross multiplication will give you dy by dt minus 3 multiplied by 0.02, which is minus 0.06, and this is your answer. Move on to example number 2. Example number 2, a curve has equation y equals to half x power 2 minus 4x raised to the power 3 over 2 plus 8x. Find the x coordinate of the stationary points. For stationary point, you have to take derivative of y with respect to x. So this constant number remain as it is. You will take derivative of x square, which will be 2x. Minus 4 remain as it is. You will take derivative of x raised to the power 3 over 2. So the power come first. 3 over 2 minus 1, and if you do 3 over 2 minus 1, you will get 1 over 2. Derivative of 8x is 8. You can simplify it. You will get x over here, and you will get 6 over here, x raised to the power 1 over 2 plus 8. The second step is to put dy by dx equals to 0. You can follow my notes. I have specified that you always put dy by dx equals to 0 for stationary point. So I'm putting this plus 8. Equals to 0. Now this is a disguised quadratic equation, and you have to use substitution in this type of situation. So I'm supposing u as x raised to the power half. Supposition is always helpful. So this equation in terms of u will become u square minus 6u plus 8 equals to 0. You can apply breaking the middle term, and that will be u square minus 4u minus 2u plus 8 equals to 0. I'm applying factorization, splitting the middle term, and you can take u common from the first two terms, and you get two brackets, u minus 4 and u minus 2 equals to 0. If you put these two brackets equals to 0, you will get u equals to 4 in first case and u equals to 2 in second case. Since you are looking for the value of x, so you have to substitute u back to x raised to the power half. And if you do squaring both sides, you will get x equals to 16 and x equals to 4. Since in the question you have to find the x-coordinate of the stationary points, so these two are your answers. The second part of this question says that you have to find the double derivative. Double derivative is derivative of your first derivative, and let me point out that your dy by dx was x minus 6x raised to the power half plus 8, and if you take derivative of the derivative, this is your first derivative, if you take the derivative of this, you will get 1 minus 6 this. And you can simplify it further, 1 minus 3, and this is your answer for the second part. Now part 3 says that find, showing all necessary working, the nature of each stationary point. Nature means whether the point is maximum, the stationary point is maximum or minimum. You need double derivative for it, and the double derivative is in order to decide whether this double derivative is greater than 0 or less than 0, you plug the value of x. You have two values of x as a stationary point. One is 16 and the other is 4. So plug it in your double derivative. I'm writing this as 3 over under root 16, and here my double derivative is and if you move on, 1 minus 3 over 4, and here it is 1 minus 3 over 2. This will become 1 over 4, and this will become minus half. So your double derivative is greater than 0, and here your double derivative is less than 0. So this x equals to 16 will give you minimum stationary point, and x equals to 4 will give you maximum turning point because your double derivative is less than 0, minus half. So this is how you decide the nature of your turning point.